All right, it's recording. So 9G, what do you need to take out? And at the sort of goals for year 8, what things I want you to know? 2 things. 1, I want you to be able to tell me the different types of gradient. And skill number 2, by the end of today, you're going to know how to find the gradient. There's 2 ways to find them. 2 ways to find gradient. You don't have to copy this down. I'm just telling you the 2 skills that you're going to be trying to achieve today. Okay? So, number 1. What is a gradient? Okay? I want you to fill this in. A gradient is how steep a line is. Okay, so what does that mean? Steepness of a line. So, for example, this pen here, when I do this, you can probably tell me how steep something is just as I'm rotating my pen. So if I rotate my pen, let's say I rotate it like this. Is this a steep hill to walk up?
Yeah.
Yes. If I make it this like this now, is that steeper or less steeper?
Steeper.
It's steeper, right? Versus if I did it like this, less steeper, which we call flatter. Right, so I'm going to draw on the screen just because it wasn't recorded. But I had this line here. This is steepness. What I showed you just now was that if I made my line like this, you said it was steeper. But then, when I gave it to you like this, you said it was less steep, which we say flatter. In an equation, which this equation here looks funny. It says y equals mx plus c, right? This equation is a general equation for any straight line. I'm going to repeat that so that you understand what I mean. If you wrote on Desmos, if you went to Desmos, and all you typed was y equals, and as long as you have just the letter x, just the letter x by itself, okay, you will have a straight line straight off the bat. I'll show you. You go to Desmos, so I go to DMOS, and I just delete all these. If I just went in and you typed in y, then you type the equals button, and you just put a letter x in it, just one x, you get a straight line. That's what a general straight line will look like, right? And doesn't matter what number you put into it now. You can put fractions. I can put something like this. I could put 1 divided by 2, so half, still a straight line. I could put big numbers. I could do like square root of 100 times 5 minus 8, and I have just the 1x there. It's still a straight line because it doesn't matter what number you put. As long as you have 1x there, that is going to make it a straight line. This is why they say that letter m is just any number in front of x. So the numbers in front of x just now, I put root of 100 times 5 minus whatever it was. That's a number. Doesn't matter what number you choose, that's called m. Then you can add a number. You can add a number plus c. I can add a number to it and it's still going to be a straight line. So watch what happens here. So I still have x. I don't have a number in front of x right now, but if you don't write the number, what number should be at the front of x? What number should be in front of x even if you don't see it?
1.
1, yeah? And that just means 1 times x. So if I put 1x, it's still the same line. And what's interesting is when I put a plus or a minus, you can say any number. I can say plus 3,000. Well, I know you can't see it because it's 3,000, it's too big. Let's do 30. It's still a straight line, even if I added a number. If I minus, say, 10, it's still a straight line. So what they're trying to say to you is you can add or subtract a number, it's still a straight line. You can times whatever you want, 2x, and it's still a straight line. So it means on Desmos, how do you ensure it's going to be a straight line? What's the one requirement you need? X, that's it. You literally can put any number you want. As long as you have just the letter x, you will always have a straight line. So the number in front of x, you can make it up. But what's interesting is when I change the number in front of x, you tell me what happens. So I go from 1, check the line, look at the line. What happens if I change it to 2? Steeper. So I'll go back to 1 again. So this is 1. Watch out. When I change the number in front of x, if I change it to 2, all right, what if I change it to 3? What if I change it to 30? It's getting? So in this notes, the larger the number in front of x, what's happening? The steeper it is. But what was that called then? The steepness of a line is determined by the gradient. So we got a special name for it. We just say, well, the number in front of x, they'd noticed that every time you change that number, 2x, 3x, 30x, all it does is it just changes the steepness. So they gave it a name. They call this the gradient. Fill that in. M, which is the number in front of x, which is the number that you're multiplying to x. You can double x, you can triple x, you can do 30 times x. That will determine the gradient. So when someone tells you, or they say, what is the gradient? They're just asking, what's the number that you're multiplying to x? That's what they're asking. They're saying, what's the number in front of x to determine how steep a line's going to be? The larger the number, the steeper it is. Fill this in. The larger the number in front of x, or the larger the gradient is, the steeper the line would be. But then how do you make it flatten then? So if you increase the numbers, it makes it really steep. How do you think I'll make it flatter then? Okay, now when you say decrease, would you say, if I decrease to 25, so yes, it's getting smaller, I'll do 20. 20 is getting a bit flatter. Let's go to 10. 10 is getting a bit flatter than before. Let's go to 5, 3, 2, 1. But then we'll put 0. It's flat. No, it's totally flat. But what happens if I go a number smaller than 0? What's a number smaller than 0? All right, let's try -1. Is that steep? No. But what if I went like this, -30? Is that steep? Yeah. So this is interesting. The number is small. -30 is much smaller than 1. But didn't I say before that the larger the number, the steeper it is? This one is so steep. It's just the other way. You're either climbing up a hill that's really hard or you're falling down really intensely, right? So this is still steep. It's just steep in a different way. It's in a bad way too. Both ways are bad. One is impossible to climb and one's impossible to go down. So this one is still steep, but what makes it steep is now not the positive or negative. It's the number. It's the value. If you make the number big, so don't worry about the signs. If you make the number big, it determines how steep a line's going to be. So, for example, if I put it back to -1, yes, it's not flat. Flat is the best. If you had to walk, which one would you choose? You'd rather a flat road than going up a hill and sometimes down a hill. It depends on how down it becomes. Because if it's too steep, no one's going to go down, right? So you still have a certain angle that you want. So the number, when we say number, it determines the gradient, but to make it really flat, close to 0, it's actually not the negative direction, it's actually fractional direction. See, if I change it to 0.5 now, oops, sorry, I'll take off the negative. I'll go back to y equals 1. The blue line is 1x. Can you see by changing it to 0.5, it's flat, flatter. But if I go to 0.3 now, watch what happens when I go to 0.3. 0.3, 0.2, 0.1. Can you see how it's getting flatter? Yeah, so that's what I mean when they say smaller. Not about the negative numbers. Negative number just swaps the direction, but it doesn't actually make it flatter. Okay, write that down. When you say smaller number, the flatter it is. Can you write a note on the side to remind yourselves it's a number between 0 and 1. Okay, it doesn't have to be negative because negative just changes the direction. It's a number. It's all about the number. So the larger the number, the steeper it is. The smaller the number has to be between 0 and 1 though. So like 0.01, 0.001, the smaller that number is, the flatter that line's going to be. Okay, that number is the number in front of x, not the one that you add to, not the one that you subtract to, it's the number in front of x. Does that make sense so far? Yes? Okay. So copy that down. So if I want a flat line, I just put a very small number in front of x, and that number has to be between 0 and 1. If I want it to be really steep, make a number really big. You can do 1,000, you can do 100, and it gets really, 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 really steep. May not be parallel vertically yet. Okay, we'll talk about those soon. All right. Here we go. The last one, the last box, which we haven't filled in, what goes into this box? Let's see if you can see what happens when I add numbers. See what happens to the line. There is a pattern. See if you can see the pattern, okay? So here we go. I'm going to go back. Here's your 1x. This is your typical line. I'm going to zoom in so you can see the pattern. All right. Here's your 1x. That's the line. So the gradient's 1. It's a normal steepness. Watch what happens when I add 1. See if you can see something, okay? So I do +1. Have a look. Okay. I'm going to do another one now. Wait, I'm going to leave it as y equals x, 1x. And the other one is, I'm going to do now 1x plus 2. Okay, so this is y equals 1x, y equals 1x plus 1, y equals 1x plus 2. Anyone see something about the numbers? When I added 1, there's something on the screen that's showing me something. And then when I add 2, there's also something on the screen. What do we see? I'll do another one. Y equals x plus 10. Here it is. Yes. Well, it's not the x intercept, it's the... Have you guys noticed that when I wrote 10, it touches the y-axis at 10. When I said 1 plus 1, it touches the y-axis at 1. When I said plus 2, have you noticed it touches the y-axis at 2? So what do you think would happen if I wrote y equals 1x and I said minus 5? It should touch the negative side. So watch. I'll zoom out. Look at that. Touches the y-axis at -5. So what do they call this? They call this number, whatever number that you add or subtract to the equation, they give it a name and they call it the y-intercept because it actually tells you where it's going to touch the y-axis. So write a note here, where it'll touch y-axis. Write that in. So the number that you add or subtract, it'll tell you where it'll touch the y-axis. Where it'll touch the y-axis. That's what that last box tells you. So C will tell you the y-intercept. M tells you the gradient, which is how steep the line is going to be. The larger the number, the steeper the line will be. The smaller the number, the flatter it will be. Okay? So far, so good? Yeah. So in the video, I described this a bit more in theory, but that's all you need to sort of get your head around next year. That's what they're going to try to really describe. So, what do you need to know for this lesson? Remember I said I want you to learn 2 things. You need to be able to determine types of gradients. There are 4 of them. And then how to find the gradient. Here we go. 4 types. I want you to fill in. So first one is called a positive gradient. It's a positive gradient when the line from left to right goes up. Can you see how from left to right looks like you're going up a hill? Yeah, from left to right you're going up a hill. That's called positive gradient. If the line from left to right looks like the line's going down a hill, for example like this one, that's called a negative gradient. Okay, that's called a negative gradient. So you got a positive gradient, which is like this. You got a negative gradient, which is, if I rotate, it looks like you're going down a hill. Then, how else can I draw a straight line? There's another 2 ways I can draw a straight line. So you got one that goes up, you got one that goes down. What's another 2? Does anyone think? How else can I draw a straight line? Any clue? Copy this one down. You can also draw a straight line absolutely flat. If it's absolutely flat, we call this zero gradient. So you either have a positive gradient, means that it's going to take a bit of effort. You're going to put in positive effort to go up a hill. Negative effort if you're going down a hill. Usually running down a hill is much less effort, right, versus going uphill. So negative effort. If it's a flat ground, when you're walking on a flat ground, it's zero effort. Yeah? Because you're not putting more effort, you're not putting less effort, you're just putting the same amount of effort. So it's zero effort. Then finally, what's the last type of line I can draw? So I can draw from left to right goes up, left to right goes down, or you can have left to right, it's flat. What's the last type of line I can draw? Yeah. I can draw a vertically perfect line that goes up and down. What do we call this type of line? Well, it's impossible to go up this hill. But in another word for impossible, we say undefined. There's more reasons to why this is, but I'll ignore that for now. Usually I describe why those are called undefined. But you've got 4 types of gradients. So first thing is I need you to be able to determine, is it positive, negative, zero, or undefined? Only 4 types of gradients. You got 1, 2, 3, 4. Copy that down. Make sure you have 4 types ready for you. And the way I like to explain it is going up a hill. So from left to right, if you're going up, it's positive. From left to right, if you're going down the hill, it's negative. From left to right, if it's flat, zero effort, zero needed effort. And then undefined is an impossible line. Can't go up that hill. It's impossible. It's a wall, unless you're Spider-Man. All right? Now, let's test you. I'm going to flip to your exercise and I'm going to pick a couple of students to see if you can tell me which of the 4 gradients it is. Here we go. Let's have a look at this one. What type of gradient is this? Positive, negative, zero, undefined. Can I please have Charlie? Positive, correct. Hands up if you thought positive. Beautiful, that's good. So that's positive gradient. Let's pick another one. What if I gave you this one? What gradient is this one? Can I please have, let's go thumbs up. What type of gradient is this one? Negative. Left to right, you're going down. So there's a negative gradient. Very good. Let's go to an example from your textbook. Let's pick these ones. What is the gradient for A? Let's go with Nick. This line. What type of gradient is that? Zero. Flat, which is zero. We call it zero gradient because you're putting no effort in. You're not going up. You're not putting less effort. And it's not impossible. So that's zero gradient. A is zero. Very good. Let's go next person. Attila. What's gradient called for C? Negative. Very good. So this is your negative gradient because from left to right, it's going down. Willow. What's B? Positive. Very good. And then last one on this side, let's go Eknor. What's D? Undefined. That's 50% of the way. So one of the skills I wanted you to know was to do exactly that. You have to be able to determine what type of gradient you have. Okay, so skill number 1 is ticked off. Number 2, well, how do you find the gradient then? How do you find the number in front of X? Depending on whether you're given a graph or whether you're given coordinates. What I'm going to teach you is 2 things. How to read it from a graph and also how to do it if you were just given coordinates and not a graph. Okay? Here we go. So skill number 1 ticked off. Skill number 2, I want you to write this one down just next to example 1. Gradient. Write M equals. This is what your Year 9 teachers would normally teach you, and they will say it is rise over run. Okay, so this, if you have a graph and you want to work out the gradient, you count how much do you have to go across and how much do you have to go up and down to get between 2 points. Okay, so this is an example. So this one. What type of gradient is this example? Can I please have Ryan? What type of gradient is this one?
That's the upward.
What's the name?
No.
You don't even know there's 4 types. Positive, negative, zero, undefined. Which one is it? Positive. Good. So, you have a positive gradient. Shh. Listening? Thank you. So we've figured out skill number 1 is to determine the gradient, type of gradient. Skill number 2 is to work out the gradient. Now the first thing I gave to you is rise over run. So what does that mean? You count. You pick 2 points. Pick 2 points on this graph that you can see. Now obviously I gave you 1, which is this one, 1, 3. You need to find another point so you can count how far horizontally and how far vertically. So I can see another point which is right at the center. Can you see that? Right at the center, it's 0, 0. The line crosses at 0, 0 as well. So if I asked you now, from this point, 0, 0, to the point 1, 3, how far do I have to go rise and run? So let's calculate. So gradient is rise over run. Now rise is how far I have to go up or down. So starting from this point, how far do I have to go up to reach 1, 3? 3 units. Can you see how it's going from 0, the y values? I had to go 1, 2, 3 to get a y value of 3. So rise, I had to go up by 3. So I had to go up by 3. So rise is now 3. How far did I have to go? So now I'm right here. So I started from here, I went up by 3. I need to get here. How far across do I have to go? 1, but it's positive 1 because I'm going on the right side. So positive 1, so up by 3, to the right by 1. So I'll write here just so that you understand. This is up 3, right 1. What's your gradient? What's 3 divided by 1? 3. So your gradient is 3. That means that in your equation, if you type this on Desmos, all you have to type is the number in front of x. If you type 3, it should actually look like this graph. Watch what happens. I'll go to Desmos, I delete all of these, and if I just type y equals 3x, and it should cross through, oh sorry, we haven't even talked about, was it 3? Yes, it is. 1, 3. Should be 1, 3. Here we go. Can you see? Isn't that exactly the same graph? Touches 1, 3. Went across 1. Up by 3. All I did was I typed the gradient. Gradient's 3. So that's one way of doing it. Let's do another one. Let's look at this side. What type of gradient do I have? Let's go with Xavier for the second example. What type of gradient is this?
Positive.
Positive, very good. This is a positive gradient. So one of the skills is how to determine the gradient from a graph. Here we go. Gradient is m is equal to rise over run. Pick 2 points and you count out how much up or down and how much left or right. 2 points, I can already see the line cross is at 0, 0. Let's pick another person. Let's go with Zara. Zara Jones, from 0, 0 to get to 2, 1, how far do I have to go up? Go up by 1, very good. So I had to go up by 1. But if I go up by 1, I'm still only here. How far do I have to go across now? Let's go with Adele. How far do I have to go across to get to this point? 2, very good. Fill this in. Rise over run. Shh. I had to rise by +1, so I had to go up by 1. And then I had to go to the right by 2. So this is up by 1, right by 2, in order to go from this first point to the next point. So what's my gradient? 1 over 2 is? What's 1 over 2? It's 1 over 2, it's half. Yeah, or 0.5. So you can just leave it as 1 divided by 2 is half. the gradient for this graph is half. Okay, so gradient is half. Copy that down, please. I'm going to pause the video. So I gave you the formula now. This is the formula to find the gradient. You use it mainly when you don't have the graph. If you have the graph, you can just count. So, what 2 points did we use? We used 0, 0, and 1, 3. So imagine I didn't give you a graph. Imagine I gave you just that. Listening? Thank you. Thanks, team. Just the last skill. Just need you to focus on this bit. Thank you. So, did you copy the formula down? Yeah. Okay, good. So, if I didn't give you a graph, and I asked you to find the gradient, so the question could be, find gradient of a line that passes through 0, 0, and 1, 3. Now, you can sketch that yourself and count it. It takes a while to do. The other way to do it now is to use the formula I just gave you. M is equal to y2 minus y1 over x2 minus x1. Looks scary, but you know all it is? It's just finding how far the y coordinates are from each other. 0 and 3. How far are they on the vertical axis? x2 minus x1 is really just saying how far is the horizontal values from 0 to 1. You see that? So, when I asked you before, when I looked at this, I said, how far is it from this point to go up to get to this point? You guys knew it was 3. But what did you do in your head? 1, you counted, or you knew this is 3 and that's 0. 3 take away 0, distance of 3. Then I asked you, how far did you go across? Some of you counted and said, well, I just went across 1. Or, from 1 and 0, how far are they? Just 1 take away 0 gives you 1. So a quicker way to do it was you can actually just line them up. You can do it this way. You can do 0, 0, 1, 3, for example. And all you have to do, doesn't matter which one's x1, y1. This is the x column, that's the y column. You take the first one, let's call that the first one, take away from the second one. So if this is the first one and that was the second one, so y2 minus y1, 3 take away 0, and 1 take away 0. So if you write that down, isn't it just 3 take away 0 over 1 take away 0? Or if you like, some of my students do this. They call this x1, y1, x2, y2, because this is the x coordinate of the first point. This is the y coordinate of the first point. That's why we call it x1, y1. This is my second point. So they call this x coordinate of the second point, y coordinate of the second point. So that's my x2, y2. It actually doesn't matter which one's x1, y1, or which one's the first or second coordinate. You can label whatever you want. According to the formula, take the y coordinate of the second one, take away the y coordinate of the first one. Take the x coordinate of the second one minus the x coordinate of the first one. Now you did that intuitively already. It's just that for whatever reason, when we put in a formula, students get this one wrong. You can do it intuitively or you can do it mathematically. Okay, so we do this mathematically. You get the same answer. 3 take away 0 is 3. 1 take away 0 is 1. And you still get the answer of 3. So it means you don't have to draw the graph. You can just need 2 coordinates, 2 different points, and you can use the rule to figure it out. Does that make sense? Yeah? I want to do another one to practice with you on how to use this rule. Can you flip over the page and go to the very last question? Flip over the page. Very last question. This one. Here we go. I gave you 2 coordinates, 0, 2 and 1, 6. You can draw these coordinates. You can plot onto the Cartesian plane and then count. but I'm trying to get you not to count. I'm trying to get you to calculate it. Here we go. Let's do it again. Formula. y2 minus y1 divided by x2 minus x1. Label your coordinates. So this is what my students normally do. They call this the first point and that's the second point, right? So this must be x1 because it's the x coordinate of the first point. This must be y1 because it's the y coordinate of the first point. Then that must mean this is now x2 because that's the x coordinate of the second point. And this is y2 for the y coordinate of the second point. Let's use a formula. Here we go. What's y2? Which one's y2 again? Is it 0, 2, 1, or 6? Can I please have... Let's go with the Qualia. Which one's my y2? Very good. 6. So the formula should then be 6 takeaway. Which one's my y1? Let's go with Belinda. 2. Can you see that? y1 is over here. So y2 minus y1. So 6 takeaway 2. Divided by Hamza. Which one's my x2? 1. And then minusing x1, Attila.
Yeah.
Which one's my x1?
2.
0. x1?
Yeah.
Copy the notes. Make sure to copy the notes. Just follow the formula. Here we go. Next bit. Now that you plot them all in, so remember the labeling doesn't matter. You can call which one first point and second point. Doesn't matter, right? Once you call them the first point, so that's x1, y1. If you call that the second one, that's x2, y2. Doesn't matter, yeah? Now let's calculate. 6 take away 2 is 4. 1 take away 0 is 1. And 4 divided by 1 is 4. So the gradient of the line that passes through 0, 2, and 1, 6 has to be 4. Okay, that's one of the first skills that you need to know. So remember, I told you 2 things today. Determine the type of gradient, and 2, calculate the gradient. Those are 2 skills you want. So 1 is from the graph, and 1 is without the graph. I'm going to give you, let's go with 2 minutes. I want you to do B now. Can you do B by yourself? I'm going to pause the video.